Teacher, your microphone is muted.
I see. Sorry about that. Yeah. Let me repeat what I said. Here, it doesn't allow, so I'm using a whiteboard right now, and it doesn't allow to record yet. I think they are going to, Teams, Microsoft is going to work on it. It's not, last semester it wasn't doing it, and this semester they couldn't fix it. So even though I started recording, it's not show. But what I could do is I can maybe get a file and I can just share the file. Okay. All right, so I was telling you about this recording. This recording will not record whiteboard. I'm going to be writing here, but I will probably send you the files. I'll be able to do that. I will give it a try. So try to take notes as if you're in the classroom, okay? Okay, let's do it like that. And let me go to the homework questions. I'm going to go, because I went over a couple of homework questions that were submitted, and I realized that there are mistakes in it. So I'm going to solve from the beginning. I'm going to solve it, and you can just refer to that. Let's see. Let me take, okay, just a sec. I need a little bit time for that. Okay. All right, so okay, the first question was, let me open up. I'm going to share the PDF, okay? I'm going to share the PDF here, and then you can take a look at those. Okay, just one sec. Okay. What I want you to do is I ask you to open up homework 1, chapter 1. We are going to solve some questions. I want you to look at the first question. Okay, I have the question here too. Just open this up, homework 1. Okay, so we are going to solve it here. That's the only way I can do. So I want you to look at that homework 1 and if you can look at it at the same time, I'm not sure, my writing here, okay? Just take a look and then I will write it here. Anyways, let me erase this all. All right. Now the first question we were talking before, y is equal, this is the first question. Okay, just a sec. Okay, this is the first question in the homework. It was y is equal to, excuse me, x 15 minus square root of x squared minus 64. And it was saying, okay, it was asked, this is 15 by the way. Okay, so it was saying find the domain of this. And where we're finding the domain, okay. Okay. Let's see. I'm trying to go down a little. Okay, sorry. So the question is find the domain of this. D represents the domain, okay? The question is this. So how would you solve it? Okay, I told you step 1, you would do, first of all, square root of x squared minus 64, okay? We have to consider this. Okay, note, this has to be reasonable, okay? This has to be meaningful. In order to be meaningful, we have note that x squared minus 64 has to be greater or equal to 0, all right? So this is the same as x squared greater or equal to 0. This is step 1. Then absolute value of x is 64, I'm sorry. It's my bad, this is 64. If you take the square root, you get the absolute value of x, and this is 8, you get this, right? But from here you have two things. Either x is greater or equal to 8, or x is less than or equal to negative 8. Okay, we have these two. Okay, this is step 1. And then, let me move this a little bit. This is step 1. I'm going to move this a little bit up. Okay, I'm going to write the step 2 here. Step 2. Step 2 is the denominator is not 0. Let me write that. Okay. Okay. Denominator is never 0. Is never 0, right? So let me see, there are some comments, let me answer them again. Yeah, paint olabilir, yes, maybe, but where am I going to get to paint? Ömer Faruk. I may not have paint. Maybe next time I should do that, okay? Okay, so denominator is not 0, so, okay. What is the denominator? The denominator was 15 minus square root of x squared minus 64, right? This is never 0, but I'm going to equate this to 0 to find the x values that's going to make it 0. So this is the same as 15 is equal to square root of x squared minus 64, okay? Okay, and then from here, take the square of both sides, 225. 15 squared is 225. square of x squared minus 64, square root of this, square of the square root is this. And then from here, x squared is what? 9, 8 to 89. And from here, I got absolute value of x is 17. See, again, I'm using absolute value. So I realize that students are not good at using absolute value, okay? So I want you to get used to it. Okay, whenever you have x squared is equal to something, or x squared is inequality, if you have an inequality like this, see, there's an inequality here, you have to take the absolute value of x is greater or equal to 8, okay? This is important. I see that you don't have that. You forgot that from high school, probably. I mean, you learned, but you forgot. And then here, we have two solutions. X is equal to minus plus 17, yeah? Now, what's the domain then? Okay, first of all, x cannot be equal to these two. Okay, these two values are bad points. Okay, so, but these are okay. So I'm going to do this. Look. Okay, from the previous solution, step 1. Okay, I'm gonna write solution. Okay, step 3. Let's write step 3. So we are going to combine the two. So how is it going to be? Look, this is x-axis, all right? This is the origin, and this is 17, this is 8, this is negative 8, and this is negative 8, negative 17, okay? So the solution is going to be x is greater or equal to 8, okay, including these. This is included, but I have to put an hole here. It's not included. And then also anything less than negative 8 is fine, but I'm going to exclude, this is going to mean that I'm excluding negative 17, okay? That's the domain. So this is the domain, and this is the domain. Okay, so how would you write it? Okay, so you would want to write it down. How would you write it? This is pictorial pictures are good. It's okay. Okay, let me move this a little bit up. So we are gonna say the domain D is gonna be equal to, okay, so we are gonna say it like this. Okay, there are different ways to write it down. Negative infinity to negative 17, open, union, negative 17 to negative 8, closed, union, closed, 8 to 17, open, you don't include 17, and then 17 to plus infinity. Okay, so that's the solution. You can write it like this, or there's another way to write it too. Okay, another way. Okay, let's write, or you can write it as follows, or domain is going to be equal to negative infinity to negative 8, union 8 to plus infinity, okay, minus plus 17. This is another way to write it too. It's up to you which way you would write, okay? All right. Hi, everyone. Okay. So can you follow on whiteboard? Is it good?
Yes, teacher, is it okay?
Okay, good. All right, thank you. So let's move on to the next question. Okay. If you want, you can take a picture. Maybe I can make it small. Just a sec. Not that. I want to. No, not that. Okay, this. Yeah, this is the solution. You can take a picture if you want, okay? If you see it, of course, on your side this small. If you can see it this small, then you can take a picture, okay? So we are going to start next question. Maybe I can move this a little bit towards left so that I have room here. Okay, second question. I want you to look at the second question in the handout, and I'm looking at that too. It says, consider the point xy lying on the graph of the line 9y is equal to 5. Let L be the distance from the point xy to the origin. Write L as a function of x. Okay, 6x plus 9 equals to 5. Okay, so let's write it down. 2 plus 9y, I think. Let me go back to it. 9y equals to 5. Okay, 9y equals to 5. Okay, they are talking about the distance. Okay, so this is a line. Actually, this line is a line. Okay, it is going to go through, let's see, whenever y is 0, 5 over 6, it's somewhere here, 5 over 6. Whenever x is 0, it is 5 over 9. Okay, it's smaller here. Okay, so it's something like that. Okay, this is the line that we are talking about. Maybe I can draw it bigger. Let me draw that bigger. Okay. This is 5 over 6, the point, and this is 5 over 9. Yeah, 5 over 9. That's right. Okay, so they are saying there is a this origin, and there is a point xy. Let's call it pxy. So we want this distance from the origin. Okay, the distance e is the distance. What is the distance of the point P to the origin? Can you write it? That's the question. Write the maybe I should write it L. Okay. Instead of T, I should write it L. Okay. This is L. All right. So how would you write that? So I'm going to move this a little bit towards right. And how would you write the distance? L is actually square root of distance between 2 points. This is the point origin 0, 0. Okay, O is the origin 0, 0. Okay, this is the letter O, this is the number 0, 0. Okay, so how would you do? This is x minus 0 squared plus y minus 0 squared. Okay, and then this is going to be equal to but I have to write L is a function of x. I have to write it in terms of x. Okay, so what I'm going to do, I'm going to use this equation and isolate y first. Okay, isolate y in the equation. Okay, so y from here is going to be what? 5 minus 6x over 9. Okay, so we are going to take this y, put it in here. So L is equal to square root of x squared plus 5 minus 6x over 9 and take the square of that. All right, so that's it. So this is the function that they are asking us. Okay, any questions? I'm doing this, but if you have any questions, let me know.
Teacher,
go ahead.
I understand everything, but I want to ask, is it over at this point, or we are going to open it more?
Say it again.
Are we going to continue the procedure, or is it done?
Here you mean?
Yes, After the isolating the y in the
No, just leave it like that. No, you don't have to expand it. Don't do
Okay.
it. Just leave it
Okay, thank you, teacher.
That's a good question. Very good. Because we want you. There was another question saying that extra work on this, then and if you need to expand it, then you would. But now you don't have to expand it. This is good enough. All right, that's a good question. Let's solve another question. Okay. Let me see what's next. I have to copy from here. I'm not sure whether I can copy snapshot here. I'm not sure. Let's give it a try. Okay. This is about the graphing. Maybe it's a long question. Maybe I should skip that. Because we don't have time. Maybe I should go through short questions, and then if you have more questions, I can tell you next time. You can work on that. Okay, find a formula for the function graph. Okay, that's a good question. Let's do this. Let me try to copy this down. Let me see if copy paste works here. It doesn't do that. No, paste doesn't work. Okay, so I'm gonna just I'm looking at question 4. Okay, I want you to look at question 4. Find a formula for the function graph. It says, okay, the first one A and the B. Okay, I think this is an easy question. Why? Maybe I can share the screen and close the whiteboard. Let me see. We can go through that like that too. And I will try if I can write it on here. Let me see. Doesn't allow me to. Okay. Let me go to share screen stuff. Okay. Okay. Now you are seeing. Homework 1, question 4. It says find a formula for the function graph. This is similar to what? This is similar to absolute value of x, right? It is kind of upside down. Do you see that? And it is shifted. Okay, do you follow me? It is shifted towards right. It is turned upside down. Okay, and it is shifted towards right. Actually, it is shifted towards. It is shifted up by 5 units, and then towards right 5 units. Okay, so let's give it a try to do it like this. Look. Yes. Emir Gümüşbaş did minus x minus 5 absolute value. What he did is, first of all, absolute value of x minus of that is going to be reflection, okay, and then you want to shift it towards right, so it is minus 5, x minus 5, that's right, and you have to shift it up by 5 units. So what Emir Gümüşbaş wrote is correct, okay, so the answer is that. You can see it in the chat too, okay, that's right. But in the question, when you look at the question here, they want you to do it like write it. So you're gonna say between 0 to 5, it is this line, and between 5 to 10, it is this line. So they want you to write it like that. That's okay. It's okay. Okay. Similarly for B, B is clear because what is this? Is it 1? Negative 1. Negative 1 to 1. It's gonna be plus 1. Okay, negative 1 to 1, it's plus 1, and then both negative 1 and 1 included, okay, and then 1 to is it 3? 1, 2, 3, yeah, 1 to 3, it is 0, but 1 is not included, and 3 is included, okay, so you have to write it like that. Okay. Okay, I think these parts didn't appear because this is a PDF. It didn't show this ABCD clearly. Okay. Any questions about the previous one? This one. This ABCD doesn't show up because it's a printout I printed from my lab, and for some reason it doesn't show. Okay, so you just need to write it down. And let me maybe write it in here for you. Comment. Okay. Doesn't allow me. Just to say. Okay. It's, yeah. I can write it here. We said that. Okay. If the answer wants it like that, that's okay. But in general, it is gonna be. I'm gonna write it like this in general. It's x minus 5. You guys know this anyways. Okay, plus 5 equals. Okay. So let me make it bigger. Okay. So this was the first one. And the second one is easy, right? But you easy means, look, here, what this teaches you, actually, the domain. So here we have to restrict our domain. The domain has to be, okay, 0 to 5. Be careful here. Otherwise, it's going to be a different function, okay, 0 to 5. That's the reason they want you to write it down. And then for B, I mean, here you have to write it explicit, like step piecewise. We just write it in compact form, okay? And then B, for the B, you should write this. Again, you have to be very careful about the domain, okay? Y is going to be equal to 1 on -1 to 1. Look at this. -1, comma, 1, and close it. Yeah, this part is important, writing it like that. And, okay, and Y is going to be equal to, I'm going to copy paste, Control C. Okay, Y is going to be 0. It's going to be 0 on what? We are going to keep this open. Look at that. Okay, it's important. Keep it open. And then this is going to be 1. And this is going to go until 3. Okay, you understand? So they want you to be aware of this writing. That's why they give you this question. Okay? All right. So that's the question. If you don't have any questions, then I'm going to move to the next one. Okay, a power company has a power plant on a river that's 240 meters wide. So we have a river here. To lay a new cable from the plant to a city 2 kilometers downstream on the opposite side costs $180 per meter across the river and $90 per meter across the land. Recall 1 kilometer is 1,000. Okay. So this is the width, 240 meters. Okay, they are going to lay a new cable to the city. Okay, this is the power plant and this is the city. Okay, but this is 2 kilometers downstream on the opposite side, but it costs $180 per meter. Okay. And pardon, I'm sorry, $90 per meter across the land, which is on here, and $180 per meter across the river. So it costs more when you want to lay it down underwater. Okay. Suppose the cable goes. So I think you understand so far. Okay. Suppose the cable goes from the plant to a point Q, okay? From the power plant to the Q directly on the opposite side. That's X meter from the point P, okay? X meter from the point P directly opposite the plant, okay? P is opposite the plant. That's what it says. Write a function Cx that gives the cost of laying the cable in terms of distance X, okay? So how would you find the cost first of all? Cost is equal to the total meters, okay, times the, excuse me, cost per meter. Excuse me. So we have to separate it into two. First of all, we are going to calculate the cost from the power plant to Q, and then Q to the city. Okay? Okay. But we are going to write it as a function. Okay, let me go back to the whiteboard. Okay, I'm going to go back to the whiteboard and do it there. Or can I write it here? Let's see. I can maybe write it here too. Let me do that here. Okay, let me put my command line here. Okay, let's move this a little bit here. Okay, and then make it big, my writing. Okay, first of all, let's find the distance between power plant and Q. How would you do that? Okay, let me call this D1. Okay, is it writing? Okay, I'm here. Okay, D1 is the distance from the plant to the Q, okay? And how would you write that? It is easy, you know that. Square root, okay? Square root x squared plus what? 240 meters, right? 240 meters and square that too, isn't it? Okay, that's the distance from the plant to the Q. Okay, and then I want to find the cost. Okay, cost 1. I'm going to call it cost 1. Okay, cost 1 is going to be what? It's going to cost me $180 per meter. So I'm going to say $180 times. Okay, maybe I should put that. Let's make it bigger. Okay, times the distance, D1. Okay, let me write D1 first. Okay, it's equal to, D1 is the distance from the plant to Q, right? This is going to be equal to, and I'm going to just copy down my function. All right. Okay, do you see that? Okay, and then next, I'm going to write the distance. Okay, let's write it. Okay, copy paste. I'm going to call it distance 2, and distance 2 is the distance from Q to the city, from the city to Q, let's say. From the city to Q, to the Q point, right? How would you write it? It's just easy, right? What is it? Can anyone say? Is it 2 minus x, or is it something else? What is the distance from the city to Q? Can you say? Selçuk, what are you saying? Yeah, Selçuk, 2 kilometers minus x, but we have to convert it to meters, right? Don't forget that. Conversion is important. These are details, but we have to do that. Okay, Selçuk. It is going to be, let's write 2 kilometers minus x, as you would say, but we should write it like 2000 minus x. How is that? Okay? Meters, actually. 2000 meters minus x. Okay? So I have that too. How about the cost 2? Okay? So I'm going to copy this down. Copy. Cost 2. Cost 2 is equal to 90 per meters, right? $90 per meters. And distance 2. And then this is going to be 90 times 2000 minus x. Okay, let me erase the meter here. Okay, 2000 minus x. Okay, cost 2. So what's the total cost? Total cost is going to be equal to cost 1 plus cost 2, yeah? And what's the answer then? What's the final answer? I'm going to just copy these guys down. Okay. This is cost 2. Here's my cost 1. It should be up here. Cost 1 is up here. Okay, so this is it. This is it. All right, that's the total cost. Any questions on this? So this is how you should see it at the end. Let me try to make it see the full picture. It doesn't show that. Let me go down a little bit. Okay, this is our solution. Okay. Okay, solution of 5. Solution of question 5. Okay, when you're writing your question solutions in a piece of paper, okay, before you submit, please try to be explicit as you can. Right? Try to write sentences like that, like distance from the plant to Q, blah blah. Okay, don't rush, because some students try to think that if they write it, if they don't write the details as much, then their homework is going to be done a lot quicker. That's not the case. You should, at the university, you should get used to writing extra information. Okay, this is gonna help you to become a better engineer as well in the future. Okay, so please pay attention to this. Okay, try to write what the formula means, the meaning, like the words. I'm writing the distance from the city to Q, and I'm writing it explicitly. Don't think that this is gonna take a lot of your time. If you get used to writing the details, and it's gonna save you tons of scores later on. You're gonna see that in any of your classes. Okay, your professor will observe that, and you're gonna get credit for that. Even if your answer sometimes may be wrong because of maybe wrong calculation, blah, blah. Okay, I want you to write it clearly like that, okay? Please make good use of it. Okay, and then B, generate a table. Okay, so did we answer? Write a function Cx that gives the cost of laying the cable in terms of distance x. We did that. Generate a table of values to determine if the least expensive location for point Q is less than 3,300 meters or greater than 300 meters from the point P. So here you are trying to find the least expensive location for point Q. So where should I put this Q so that the cost is going to be the smallest? Actually, this type of problems we are going to handle in one of our chapters, okay, which is optimization. We are going to see it, okay? Optimization problems. It's going to help us to do it. We are going to use the derivatives to do that. But here we are assuming that we don't know derivatives. So it's just saying, why don't you make a table and then try to look at the answers and then try to find a good location for x. Okay. So we go back to where's our formula here? Let's build this table. This is good. Okay, these are all good. Okay, so this is actual total cost is our Cx, C of x. Okay, C of x. All right, and then so we are going to find C of 0. What is C of 0? C of 0. All right, C of 0 is what? And then C of I think 200, was it? Just a sec, let me move this a little bit. 200, 300. I want to collapse this a little bit. Okay, this much I need. Okay, this is good. C of 0. And then I want what? I want C of 200, 300, 400. So I need 5 of those. All right. So I have C of 200. Okay. and then I have C of 300, and then I have 400, and then 500. Let's see which one is the best. I mean, almost the best, because unless you learn optimization problems in the future, in coming chapters, this is not going to give you the best one. This is just going to give you an estimate, okay? So we are going to put 0 for x, so square root of 200, yeah. So this is going to be, copy, I'm going to just put it in here, and then I'm going to say x is 0, so this is 0, I have this, I have this, whatever this is, okay? We have to calculate this by using a calculator. So in this case, 200, okay, squared, and this, okay? Can anyone do the work? Can anyone calculate this by a calculator while I'm writing this down and tell me the results? Can any volunteers do that for me, please? Like, what is C200? What is C0? I need your help. Okay, and then the last one, which is 500. Okay, you can consider that these questions are easy. Okay, it's possible you can consider that, but you don't want to look down on the questions, because if you see, oh, this is very easy, I can easily handle it, then it is possible that you're going to make a lot of mistakes. Okay, you should value each question no matter what. Okay. Okay, so Selçuk, can you help me with the calculation if you have a calculator, or anyone else? I can have 5 people. For example, I can. Okay, Selçuk, can you do C of 0 and tell me the result? C of 0 though. C of 0.
I am doing it, teacher.
Okay, who are you? Selçuk, you are doing it. Okay. And Süleyman, can you help me with C500?
Teacher,
Süleyman?
I'm able and I can do the 400 if you want.
Okay, please, could you do that and help me so that we save time?
What should I do?
Süleyman is gonna do C500, I said, right? C500.
Okay.
I'm really bad at writing C parentheses here, right, making mistakes. Okay, and then who else can help? Sude, can you help me? Sude. Sude is
Yes,
gonna
teacher,
do
I can.
C300, please. Okay, thank you. Jamal wants to do it, I guess. Jamal, can you do C200 is missing?
Teacher, can you show us the question again?
Sure, right, yeah, it's here. Okay. 400, did I assign 400 to anyone? Probably didn't.
Yes. No, I have it. I have the 400.
Great, perfect. Okay, let me get the answers when you're ready, okay? Yes, Süleyman, I'm showing you that. I can also actually put it in the chat. Let me copy paste in the chat so that you can see it. Okay, let me do that. Okay, here are the equations in the chat.
Teacher, I found something really strange, but I'm going to write it in the chat box.
Okay, please go ahead.
This is the 400, okay? I think I should write it down.
Please write it. Yeah, that's what I want. Actually, I want you guys to get used to writing explicitly, because that's what math does. People are losing points because they are not writing explicitly. Okay, please get used to it. Thank you.
Teacher, I use the calculator. Is that a problem?
No. You can use calculator in the homework, no problem. In the test, you're not allowed to. In the test, actually, for some questions, I will see if I assign a question that needs a calculator, I will tell you, okay?
Okay.
Unless you're not going to use a calculator in the test.
Teacher, should I explain it more in the chat box, like you said?
Yeah, I mean, you can. Well, you wanna? Yeah, you can if you want. Okay, so since I'm not going to check your answers, I'm gonna just decide what you give me. So your inputs, I'm gonna talk according to your inputs. Okay, so and I'm gonna assume that they're all correct. Okay, so according to the inputs you gave me, for example, x is equal to 0, it's gonna cost 223,000. 200, and this is not too bad, but is it really okay? Emir's result is what? 227,965.707. So this is worse than the C0. C400 is not good. And how about Jamil's answer? Let's look at the Jamil's answer. Jamil, what is the answer? Can you give me the answer? I'm waiting for your answer. And Sude, are you sure about that? Okay, that's good. That's okay. 220. Sude is the best so far, is it? Let me compare it with the first one. Yeah, Sude is the best in terms of the answer. It's the least cost. And Süleyman's is the actually least, 99,000 around. Okay, 99,000. So Süleyman, okay, so then if x is 500, then it's the least. Okay, so if the Süleyman's answer is correct, then I think, Jamil, are you going to give the result? We are waiting for your result, C200. Did you calculate it? I can't see it here. So far, the best is Süleyman. Did you change it? Oh, okay, so Süleyman corrected it. It's not good. Okay, okay. So I'm gonna put some. Okay, so this is not good. Süleyman's is not good, and then Emir's is not good. It's too much in terms of that. Okay, it's not good. So this is okay. Sude's is okay. So far it is good, but I'm waiting for Jamil. Can anyone calculate C200 quickly? I think Jamil is lost. Probably he's dropped down the system. 1 million? It is too much. So so the best is Sude's is the right one. I think the best one. It's gonna cost the least. So if in the picture, if they put Q like 300 meters away, okay, from where though? Okay, is it from city or from P? Which one? Let's say 4 point Q, yeah, or greater from point P. So X is this, so it's 300. So it's going to be 1700 away from city Q. So it is the best among all these so far. Is the least expensive 4 point less than 300 meters or greater than 300 meters from point P? Okay, this is another question. So they are asking you more. Look at that. So they want you, okay, we found 300, right? So we want to just, they ask another nice question. Look at this. Should it be less than 300 or bigger than 300? How would I know? How would I know? Can anyone guess? How should I answer that? What should I try? Can anyone answer this question? This is a nice question. So for the book, it's not enough just to find the best among the 5, but they ask you, is the least expensive location for point Q less than 300 or greater than 300? What would you say? How would I know?
Less than 300.
How did you conclude that?
Actually, it could be nonsense, but Hocam 500'den 300 çıkardım, 200 oldu.
Yok.
Ya aslında ilk önce 300 dedim. Çünkü zaten hani 300'ü bulduk ya, C300'ü. C300'ü bulduktan
Tamam,
sonra
onu bulduk. Hı hı.
oradan sonra hani 500 metrelik bir mesafe olarak aldım. Doğru aldığımı bilmiyorum ama 300'den 500'e de 2 kalıyor. Yani saçma olabilir ama aklıma bir tek bu geldi.
No. That's not the scientific way approach, okay?
Teacher, sorry.
Go ahead.
I think the hypotenuse en büyük olmalı.
Okay, but why is that? If the hypotenuse is the biggest, is it the best? Because the cost underwater is more than the cost on the ground.
Because of square.
Maybe it should be the other way around. It should be the least. Maybe the hypotenuse should be the least, isn't it? Because if the hypotenuse is the most, then that would mean we would pay $180 per meter, and hypotenuse is the most. Okay, do you understand what I'm saying, Umar Faruk?
Teacher,
So I
actually no.
Okay, so we have it. Okay, let's do that. Let's go back to our whiteboard, maybe. Maybe let's take a break, and I'll let you think about this during the break. Okay, I need a break too. Okay. Let's think about this during the break and come back with an answer. Okay, bye-bye. 10 minutes break. We meet at what? 10:05. Thank you. Bye-bye. Okay. Hello, everyone. So you have
Hello,
seen,
teacher.
have you seen MyLab? Pardon, have you seen Wolfram Alpha? Or can you see my screen now?
Yes, we can see it.
Okay. Now, so we had a question that which one would be better, like less than 300 or more than 300. So I have a suggestion for you. Use Wolfram Alpha and plot this graph. Okay, let's plot this, which I did already. Okay, let me actually copy paste this Wolfram Alpha to this chat as well, so that everybody should use it sometime. I mean, whenever they need. Okay. So yeah. Hi, Eylül Başak. Okay, so here's we draw the graph. Let's see whether the graph is going to help you. Do you think the graph is going to help us to decide? Can anyone say? Can you comment on this? Like, if I draw the graph, is it going to help me to make a better choice?
Exactly, teacher.
Yes.
Yes. So let's refer to it. That's why actually we are all working on the behavior of the function. Do you understand? The reason we work on the behaviors of the function, because it helps us big time. So this is our function. Okay, this is the cost function, and this is the graph of that. Do you see that? And look at the 300s. So this is 5,000, 1, 2, 3, 4, 5. So this is 1,000 here. And 300 is somewhere here. And do you see that the function is after 0, it is going up? So we are interested in the least cost. So it should be less than 300, right? Do you see that? Because it's going to give us less cost. Okay, so that's how you should get to the answer. So you have tools. For example, you have the graphs, you have some other computations. You just think about all of these and choose the best tool that you can get to the answer. Okay, so but you might have different thinking as well, guys. For example, Ömer Faruk said that maybe we should have the hypotenuse the biggest. Look at that. Look at the picture. We want x to be less. Why? If it is less, then we are going to have more on the ground, right? Because on the ground it costs less, $90 per meter on the ground. But in water, it is $80 per meter. So we want the ground more, but the underwater less distance. Okay? So probably Ömer Faruk meant the other way around. He wanted the hypotenuse to be less than it should be, so that we are going to have less cost in the underground, because in the underground it costs more, right? It is difficult to lay a cable underground, underwater actually, not underground, underwater. So you have to think about that. Okay, let's move to the next question. For the given functions, find the domains, range, blah, blah. Do you have any issues with that? Do you want me to do it, or are you okay? If you don't want me to do it, I'll skip. Okay, so what you're gonna do, you are, okay, the domain f you know how to find. X plus 3 has to be greater or equal to 0. And for the range is gonna be 0 to plus infinity, right? And similarly for G, but for f plus G, you're gonna take the intersection of the domains, yeah? We learned about that. Okay, f times G, you're gonna take the intersection of the domains, but f over G doesn't have the f over G. F over G should be somewhere. No, okay. All right, so I'm gonna skip that because I thought that you guys know. The graph to the right shows the graph y is equal to negative x squared shifted to two new positions labeled A and B. Okay, write equations for the new graphs. You guys know shifting very well, right? Can you write the answer to A and B in the chat, please? Very quickly. So you are shifting A is 2, I mean 2 units to the right, you get the blue one, and -5 units to the left, you get the red one. Please write the equations very quickly in the chat. Okay. But you are, Emir, you are doing shifting towards right and left. It should change X, not Y. Your answer is not right.
Can I see the question again, please?
Okay, sure. You are shifting the black one to the right and to the left. Okay, so let me see the answers. Okay, anybody else? Okay, Ahmet Kendirli says +5. Ahmet, if you add +5 to X, it would shift it to the right. I mean, to the left. Yes, that's true. You got it right. Yes. No. Your answer was right. Okay, shifting towards left, right? So it should be +5. You were right. And we are shifting to the right. It should be -2, right? Okay, so it's gonna be, Ahmet, can you write the one shifting towards right? So, okay, or maybe I should write the answer. So y is equal to negative, in parentheses, x. I'm gonna write the +5 first, +5. This is shifting towards left, okay? Squared, this, okay, and then we are gonna do shifting towards right. So it should be -2, but 2 units, okay? So this is gonna be this, okay? So the first one is actually in the picture B, I guess. Let me see, yeah, it is. The answer to, all right. Okay, let's see. So do you guys all understand what I'm doing? Okay. You guys are with me, right? Let me see how many students I have here, 49. Okay, so students who are quiet, I understand that they can follow and they can understand, unless they ask me a question. I mean, if you don't understand, please ask me a question, okay?
Okay.
Yeah, any questions? Okay, it says graph the following function by starting with the graph of y is equal to x cubed and applying an appropriate transformation. When you look at this, what should I understand? Excuse me. How can I handle this? I have to do something about that first. Any ideas? Anybody knows how to start? So let me write the question. Y is equal to, in parentheses, 1 minus x, x cubed, and then what? Plus something, a minus 4. Okay, anybody, anybody knows how to start? I'm going to give you a hint.
Yeah.
Okay, the hint is,
1, 2.
I'm going to give you a hint. Look, I should give you the hint here. Okay, let me do the comment line here. Okay. Okay, hint is as follows. You want to, okay, would you agree with me? Okay, I'm going to rewrite this as follows. Look at that. Is this the same? Are they the same? Yes or no?
Yes, teacher.
Yeah, they are the same. So this is much familiar to previous one is really difficult to handle at first. Okay, now we can talk about that. First of all, you see that there is a shift towards right by 1 unit of x cubed. So we start with the y is equal to x cubed. Okay, let me write this for you guys. Okay, just a sec, give me a little bit. So we are going to start with this. So it is what? Then shift to the right by how many units? 1 unit. Okay. Or you can actually first reflection, do the reflection if you like. Either one is fine. Then reflection, then reflect across x-axis. Okay, because you have -1 in the front here. And then you're going to shift down by how many units? Okay, so this is it. Do you see that? Yeah. So in the picture, you have to do it. So which transformations will be used to transform y is equal to x cubed to the given function? Select all, apply. Reflection across to x-axis? No. Reflection across to y-axis? No. Reflection across to x-axis? Yes. So these okay. So our answer is these okay. Horizontal stretch compression, horizontal shift. Do we have horizontal shift? Yes or no?
Yes.
Horizontal
Yes.
shift means
Yes, we do.
1 unit.
okay, and then vertical shift. Do we have it?
4 units.
Yes, we do. Vertical shift we do. So we have it here. So DCE is the answer because we shifted by 4 units up, down. Sorry. Okay, so these are the things that we did. Okay, then you draw the graph, of course. Okay, so I'm not gonna draw it here. You can just try to draw it on your own. Okay, solve for the angle theta. If you don't have any questions, then I'm gonna move to the next one.
Hocam pardon. Y-axis olmayacak mıydı o reflection?
Across okay, let's go back to it. Reflection across y-axis means you are reflecting. If you put, look, let's open up our thing here. So see, this negative is in front of this. Okay. For example, how would you shift? Do you remember the absolute value? Y is equal to absolute value of x, right? We did this example. So just a second. We did this example, and then we said, let me write example in the front. Example. Okay, and then we put then reflection across x-axis is what? We just put negative in the front. So all the positive y values becomes negative values. So you are reflecting across the x-axis. Yeah, through the x-axis. Okay, along the x-axis. Is that okay? Okay.
Okay.
So, it's like this. You put in front of this. You are changing the y values. Y values becomes negative values now. So that means your mirror is on the x-axis, right? Mirror image. Like you have a mirror, then you reflect along this mirror. And your mirror is x-axis, not y-axis. Okay. Okay. Any other questions? If not, let's do this. Okay. So for the angle theta, where theta is 0 to 2 pi, cosine squared theta is equal to this. Let's see. So how are we going to handle this? Let's write it in here. Okay. Okay. Is it the same as cosine absolute value of, is this equal to, okay, absolute value of cosine theta, okay, is equal to Oh, okay, okay. Don't do that. Sorry. If you do that, remember what? Remember double angle formulas. Okay. What was the double angle formulas? Can anyone remind us? For example, do you remember this? Cosine 2 theta is equal to, okay, 2 cosine squared theta minus 1. Anybody remembers this formula? I mean, this should be cosine 2 theta. Yeah. Okay. Instead of theta, I can use 2x. Let me write it 2x. It's clear. It's better for you. Cosine 2x is equal to cos 2 cosine squared x. This is double angle formula. Now from here, I can easily choose cosine squared x. Just a sec. And sorry about that. So from here, what would you do? You're gonna write in terms of cosine theta. Okay, let me do that like this. Okay, and then from here, okay, 2 cosine squared. I'm gonna isolate that. From here, do you agree that? I mean, pardon. Equal to 1 plus. Okay, over 2. Okay, this over 2. Do you guys agree with that? Okay. Yes. So now, do you agree with that? Let me get comments. Okay. So, so this is gonna tell me that, okay, I copy paste this, and I'm gonna say this is equal to 2 minus square root of 2, all right, over 4. Okay, now I'm gonna solve this one. Okay, solve this. Solve for x. Okay, I'm gonna do this like that. Solve for x. This. Okay, in this equation, I'm gonna solve for x. Okay, solution. How am I gonna solve it? I am going to, okay, I'm going to take g of the 2 here, so it's going to become 2 here, okay, and then this is the same as 1 minus, okay, let me see, 1 minus square root of 2 over 2, over 2, okay, on the right hand side, okay, I have this. I can even get rid of the parentheses here because I don't have 2 anymore. All right, and then I can cancel the ones. I'm gonna cancel the ones, look. I'm gonna cancel the ones, so I have this now, okay? But in here, I can easily cancel the ones. Okay, because we have 1 on both sides. I'm sorry, just the ones here. So cosine 2x is equal to negative square root of 2 over 2, okay? And then I ask myself, cosine is gonna be negative where? All students take calculus. So, except first quadrant, okay, cosine x, cosine is positive I mean, is negative, I should say, negative. Is negative on the second and the third quadrant. Okay? So it has to be, it has to give me square root of 2 over 2. This is 45 that they are talking about, okay? So then 2x is going to be equal to what? Negative square root of 2 over 2. 2x 35 degrees. Or you can write it in terms of pi, 3 pi over 4. 3 pi over 4. Okay? Or add pi to this one, or 90 degrees actually, right? 45, and it's going to be 5 pi over 4, I guess. 5 pi over 4. Okay? 5 pi over 4. This is 5. Okay? And from here, I have two solutions. Okay. Okay, solve this and get what? X is equal to 3 pi over 8. Okay. And then solve this and get 5 pi over 8. Okay, so we have two solutions, and it's saying find it between 0 and 2 pi. So we got two solutions. Actually, this x is the same as theta here. I just renamed it theta, x, okay, to make it easier for you. Okay, so let's see the whole picture here. Okay, so what did we do? We just used the double angle formulas here. Okay, remember double angle formulas, which is cosine 2x is equal to 2 cosine squared x minus 1. And then cosine squared x, I isolated cosine squared x. So I have cosine squared x here. I isolated it here. And I wrote it in terms of cosine 2x. Okay, and then cosine squared x is, then I wrote the equation, because this is equal to cosine squared x is equal to this. This is the given equation. Let me write that. This is the given equation. Equation in the question. Okay. And then I solve for x in the equation. This is the equation that I have now. Okay. And then I want to solve that equation. Solution. I have 2 here. I have 4 here. I got rid of the 2. Okay, I got this left, and on the right hand side I have 2 here instead of 4. 2 over 2 is 1. Square root of 2 over 2 is square root of 2 over 2 here. Okay, so then look, I have 1 here, I have 1 here. Okay, so from this equation I got this equation. I just get rid of the middle step because I don't need this middle step anymore. And then I go down. And then I exclude these ones. Cosine 2x is equal to negative square root of 2 over 2. And then cosine is negative on the second and third quadrant. Remember, all students take calculus. Yeah. All students, all of them are positive in the first quadrant. Sine is positive in the second quadrant. Tangent is positive in the third quadrant. And cosine is positive in the fourth quadrant. So this is going to tell us that cosine is negative on the second and the third quadrant because it's positive in the first and the last. So from this equation, I got that 2x has to be either 3 pi over 4 or 5 pi over 4. Then I solve these two equations. Solve 2x is equal to 3 pi over 4, and we get we get x is equal to 3 pi over 8. Okay, this is the first solution. And then solve 2x is equal to 5 pi over 4. We get x is equal to 5 pi over 8. And we are done. This is finished. Okay, that's how I want you to do it. Okay, any questions in this?
No, teacher.
Okay, perfect. Okay, this is a question about, again, shifting. Okay, for f of x, identify A, B, C, D, blah, blah, sketch the graph. A, B, C, D is clear. Sketch the graph, let's remember. So we have x minus pi over 2. This is shifting towards right by pi over 2 units. This 3, it's stretching 3 times this. It's going to stretch the y values. Okay, and negative 2, it's going to be shift down by 2 units. And you can easily graph that. I'm going to skip that. And these are the answers. See, at the end, you can see the answers here to check your answers. Okay, I gave you the answers. Now look at the results. Okay, so these are C0, C200, 300, 400, 500. Less than 300 meters is the answer. Do you understand? Okay, you have the answers here too. Okay. Okay, here. 3 pi over 8, 5 pi over 8. We got, oh, these are small. We have 2 pi. We have to enlarge it because this is less. So we have 2 more, right? Because these are still less than pi. And we have 0 to 2 pi. So we have 2 more, which you can get it by adding, okay, pi to it. Okay, maybe we should add here that okay, we have to okay, we have more actually. We should say 5 pi over 4, 45 to 25, but we have to go for the positive as well. 11 pi. Okay, we can add. Okay, why is it 11 pi? Why should we go? Let's see. If you add to make it 11, you have to add 2 pi for it. Because the reason, look, if you add 2 pi to it, 8, 11, yeah, you have to add 2 pi. Okay, okay, be careful here. Note, let me write this and then write that. Or we have to go for a little bit more. The reason is, okay, and what else? We have to add 2 pi, 8, 13, or 13 pi over 4. Why is that? Okay. Why? Because the answer requires 0 to 2 pi. Okay, because of that we have to go a little bit more. Okay, 0 to 2 pi here. 0 to 2 pi. Okay, 0 to 2 pi. Because of this, I have to do a little bit more because actually I have 2 more results here that's gonna give me. So I'm gonna do that. 11 pi over 4. It's gonna be again. Okay, how did I get this? Let me tell you that. Okay, let me explain it too. Okay, I got 11 pi over 4 by adding 2 pi to it. Okay. Note, I got by adding 2 pi to this. 2 pi plus this, because otherwise it's not enough. I don't cover all of it. I have to go 2 pi more. And then, similarly, 13 pi over 4, I add 2 pi to it. Okay. Okay, I got these guys. And so I have to add this to as well. Otherwise, we miss 11 and 13. Okay, be careful about that. And we get x what's 11 and 13. Okay? Now this covers it all. Now we get all of the solutions, otherwise we would miss. I mean, okay, we would miss 2 solutions. Okay, done. Okay. This is a detail, but you have to be careful because it's very easy to make mistakes in here, like I did as well. Okay. We can draw a picture to draw this, but okay, let me draw a picture for you too on, let me see, where's my whiteboard? Okay, I'm gonna draw the picture, okay? This is not gonna be recorded, by the way. Whiteboard is not recorded, so you would want to write it down if you want, okay? But you can see it now. Let me move this a little bit. Okay, towards right. Okay, let me draw that. Okay, let's see. Okay, so this one is 3 pi over 4. 3 pi over 4. Okay, and then this is 45 degrees. This is 45 degrees, pi over 4. 45. I mean the size, pi over 4 degrees. And then this is 5 pi over 4. Can you see it, or is it not dark enough? I thought that this is not dark enough. Let's see whether I can make it darker. It doesn't allow me. Okay. Okay. Can you see it clearly? For some reason, it's not the best. Okay. But look, we have, I'm going to draw another one because otherwise it's going to be too. Okay. If you move 1, 2 pi and then come back to this, and this is going to be your 11 pi over 4. Okay. And still we can use that. Still cosine is positive here. I mean, a negative here, I'm sorry. And it has the square root of 2 over 2. And then for the other one, we turn 1 around and then come back to here. And this is what? 13, not 15. 13 pi over 4. Okay? Still cosine is going to be, but this is cosine 2x. That's why we have to consider the 4 of them. Okay? Then we just say, we have to just consider this, this, and this, and this, all of them. Okay. So that's why, if you do just these two, it's not enough. Because this is 2x, not x. If it was x, x would be 0 to 2 pi. But 2x, we have to consider 0 to 4 pi. Okay? Twice of the 0 to 2 pi. Okay? Okay, that's what I want to say. Okay, so we finished the homework 1. Do we have time for homework 2? We have 10 minutes. Okay, I'm going to go to homework 2. If you don't have any questions. Okay, let's open up homework 2. Where's homework 2? Let's see. Should be somewhere here. Not that. Okay. So let me open it up. Do you have any questions about the pre-calculus part? I can solve pre-calculus as well. I have pre-calculus opened up here. Do you guys have any questions? Do you want me to solve? Let me solve a little bit pre-calculus.
No, it's
Same.
easy. I guess there's no question about it.
Okay, good. And then let's see. Let me open up the homework to here. I thought I opened it up, but seems I didn't. Okay. 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 The first question is find the average rate of change of the function over the given interval. You find it. Do you want me to solve it or are you okay? Let me do it anyways. Okay. Okay, so what's the average rate? It is delta P over delta theta, right, in this case. So we are going to just write the delta P. Delta P is, okay, let me write it like that. Delta P over delta theta, okay? Okay, this is equal to, as you would know, it is P of 5, all right, minus P of 4, okay, and divide this by 1, okay? So I'm going to close it, okay, and then divide it by 5 minus 4, which is 1, okay, 5 minus 4, okay, so it's what I need to calculate. So for that, I need to find P of 5, P of 4, okay? I'm going to go back to my Wolfram alpha for that. What is P of 5? And I need to go and find it. And what's my P of 4? Unless, of course, you want to work on it and do it on your own. By hand, you can do it too, but it's going to take time. Okay. Let me see whether the way to... we can do some algebra to get that actually. Okay, let me do that on Wolfram alpha. I'm going to go to theta cubed minus 5 theta squared. Okay, let me write, go back to Wolfram alpha. Okay. Okay. Find. Okay. Find. So anyways, let me not do it because it's going to just calculate this. Okay. It's going to take a little bit of time. Let's look at 2. Find A, the slope of the curve at the given point P, and B, the inequation of the tangent line at P. Okay? So, how would you find the slope of the curve? Okay, we don't know the derivatives yet. And, okay, but we can just get to it. Okay? Okay, so you're going to do the average thing again. Okay, you're going to build a table. And then after you find the equation of the curve, of slope of the curve at the point P, then you're going to use that slope to write the equation tangent line. This is easy, okay? But the first part, slope of the curve at P, is not easy, okay? You have to build a table, okay? So I'm going to start with answering the part B, because I'm going to just tell you what you really need, okay? Okay, let's see. Okay, so this is 2B first. In the 2B, I'm going to tell you what you need. Okay, let M be the slope that we find in A, defined in part A. Okay, I have 4 minutes, so I'm kind of rushing. Okay, then what you would write is, we have a point, so we are going to say y minus -3, okay, it's equal to m times x, pardon, not -3, I made a mistake, -70, right? Because y value, m is equal to m times x minus, okay, -3, it's going to become +3. Let me write this right away, okay? So this is going to be the tangent line equation. Okay, just a sec. Tangent line equation. Tangent line equation. This is tangent line equation. Let me rewrite it, but I'm assuming that we know the slope. Okay, and let's say we know slope. Let me rewrite simpler way, plus this. Okay, but how would you find A? Okay, for A, so far we don't know derivatives. If we knew derivatives, let me see, why doesn't it? Okay, just a sec. If you knew derivatives, this would be piece of cake. Okay, very easy. All right. What you could do is build a table. Okay. And by using the average rate formula, average rate change formula, right? Okay. What was it? Average rate formula. Okay. F of, let's consider this as f function. Okay. It would be f of, if you remember. Okay. F of -3. Let's see. F of x, a plus h, which is -3 plus h, okay, minus f of -3. Let me write that. F of -3, okay, over h. Over h. So this is our average rate of change formula, and then we are going to let h take values close to 0. Okay. Look at the table that you built. Okay. Okay, determine the slope from there. Determine the slope from the table. It's what we did in the past, right? And then this is going to be an approximate value for it. It's not going to be the exact value. Okay. Okay, this will be an approximate value for the slope. Okay, it's not going to be exact. It will not be the exact value. Okay. And then call it m. Of course, it's going to have a value. And then we use that slope in question B to find a tangent line equation. That's how you should do it. Okay. These are the steps to follow. Okay, time is up. These are average rate formulas again. Questions. So they are talking about the slope of the secant line. See, we have secant lines here, P to Q1, P to Q2, P to Q3, P to Q4. They want you to find approximately by looking at this table. You're going to just look at find the distances between PQ1, PQ2, PQ3, etc. Right? You can find it. And what else I gave you? Which of the statements I about the function graphed here are true and which are false? Okay, these are about limits. Okay, we talked about, actually we have not started limits as much. Okay, this is about approaching the limit. For example, limit as x approaches to 1. Okay, as x approaches to 1, what is the limit? From the right and left, you look at the height. The height is 3 from the left, the height is 3 from the right, so the limit at 1, it's going to be 3. So, it says the statement limit doesn't exist is false because it exists. The limit at x is equal to 1, it exists. From the left and from the right, it is. The statement limit x goes to 1 is equal to 1 is, it's not true because as x approaches to 1, from the left and right, it is 3. This is false. As x, excuse me. So I want you to watch my video on this, because you would need that. I think we talked about these, right? No, I'm not sure. You will directly plug in the value here to find the limit. For this one, you're going to directly plug in this value, so it's going to give you the limit. For this, you have to look at the quotient. What is it called? You take the adjacent, not adjacent, I forgot the name. Square root of 4h plus 1 plus 1. You have to multiply the denominator and numerator with the negative of that. And then you're going to rationalize the denominator like that, and you're going to get the limit afterwards. Okay, but actually you don't need it here. It's easy. You just plug in h, you get 1, 1, so it's reasonable. You just plug in h. It's okay here. But sometimes it's not okay. Sometimes it makes undefined in the denominator. Then you have to multiply with the conjugate. We call it conjugate of this expression if you put minus in between here. In this case, you don't need. And for this, t goes to 17, it makes the denominator 0. So you're going to separate, you're going to factorize numerator and denominator and see if there are some cancellations. Okay, you're going to do it like that. For this one, find the limit. What you're going to do, I'm going to be almost done. This is the last question now. Try to simplify it. Plug in first, but it's not going to work because denominator is not, you cannot make it 0. Maybe equate the, denominators in the numerator and see if there are any cancellations, and then do something. And it says type it into, just to say, okay. And then for this one, you need actually, I think, if you plug in this, it should be square of 19, and it's going to be 0 in the denominator. You need to multiply the numerator and the denominator with the conjugate of that, which is square root of x plus 22 plus square root of 19. Okay, find the limit. You can directly plug in pi here. It's going to be no problem, I think. And then, so you have to work through that. I'm not going to talk much about that. And this is this one, average rate of change formula here. Do you see f of x minus f of x over h? And then you're going to, here is the f, and they want you to do it. So you can do it. And this is sandwich theorem, which we are going to go through. You have to follow the videos that I'm going to send. And this is this is piecewise function. Okay. And you're going to look at this picture and determine the limits like that. I'm going to skip that. 16, where's 17? 17. This is a piecewise function too. I'm going to talk about this. This is a special type of function I'm going to talk about in the video. Okay. And then it says graph the function. piecewise function, you're going to graph it. And then after the graphing, you can choose the left limit, right limit. We will talk about the one-sided limits later. And this is about absolute value. This is an important thing. I'm going to talk about this in the video. And sine theta over theta, this is special. I will talk about this limit in the video. And this is again special function. I'll talk about it in the video. And this is also a special thing. I will talk. And that's it. Okay, that's it. Okay. You can ask me your questions through chat, through here. Okay, Ridwan, you have any comments? Okay, so if that's it, then we stop here. We passed 2 minutes over our, how many minutes? 7 minutes actually. I need to go to my meeting as well. Take care. Talk to you later, okay? Bye-bye. Okay, students who doesn't have the access code, Sudenur. Okay, send me an email again, Sudenur, and I will forward again. Probably Ismail Bey just missed your email. Did you send email to bookstore as well, Sudenur?
Yes,
Okay.
I did. They responded me this morning by saying that you need to send me the decon that they said.
Okay, they want to see that you paid for it, right?
Yes, I did.
Okay, send me an email as well. Maybe I can forward it
Okay.
to Ismail Bey. Ismail
Okay,
Bey. But you should follow with the bookstore as well, because Ismail Bey, what Ismail Bey is doing is sending things to bookstore. So bookstore has to fix it. It's their problem. They have to fix it. Okay, they're responsible for it. Okay, sorry about that.
Update you, I guess. Do you want?
Yes, please do that.
Okay.
Okay.
Thank you.
Take care. Bye bye. See you.
Bye.